Leetcode 322 coin change. It's a medium type problem, and it's also an entry-level problem when it comes to dynamic programming, which is a strategy that you may use. It's even the most obvious choice for such problems. And if you are getting confused or just starting with dynamic programming, then definitely study this problem in depth, since it only gets more complicated. Yeah, it's like an entry level when it comes to dynamic programming. And here's the description. You are given an integer array coins representing coins of different denominations and integer amount representing a total amount of money. Yeah, so basically coins is the first input, is a list of ints in Python, and those are the types of coins that you may use. Like, let's say coin of value 1 or coin of value 10. Yeah, it can be anything, it's just limited by integer. Yeah, and amount is a single integer, and from those coins you want to construct this amount using as little coin types as possible. Yeah, but each coin type can be chosen any number of times. And here is the further description. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. And of course, it could be the case that, for example, here they give you some small amount and all the coins are big. Yeah, let's say you want to have amount of 5, but the smallest coin is 10. It is the case. Or for example, you want to construct 11, but you have just 5 and 3. Yeah, and in this case you cannot construct, and if there is no such combination, then you simply have to return -1. You may assume that you have an infinite number of each kind of coin. Yeah, so here are just types of coins, and you can add each type as many times as you want. And here's an example: 1, 2, and 5, and the amount is 11, and of course the output is 3, because you can choose 5 2 times, and then you get 10, and 1, and you have 11. You could also have chosen 2 5 times, yeah, but then you would have used more coins than here. And we want to have the smallest amount of coins, as little as possible. And the second example is when we don't have an option to choose coins to create such an amount, because amount is 3, and a single coin equal to 2. Yeah, so you cannot, there's no possible way to combine 2's in such a way to get 3. And the last one is amount also can be 0, so the next edge case, and in this case you can also have 0 amount of coins that you can choose. Yeah, so those are the edge cases that you have to keep in mind. And the normal situation is when you can have multiple options and you have to choose like the most optimal one. So let's maybe take this and put it here. And let's copy this as well. The name of the game is Dynamic Programming, as we have already mentioned. And if you are new to it, then basically it's not like one strategy or one formula that you may use, as in backtracking, let's say, but whenever you have one big problem, and this big problem can be deconstructed to multiple sub-problems, and at best those sub-problems are repeated. Yeah, so then you can use something like a cache, which can be used either recursively, and then it's called memoization, or you can store it in some kind of array or list, and then it's called tabulation, which we will use this time. And then you can basically reuse those easy to compute sub-problems in order to arrive at the final answer. Yeah, and we will discuss it in detail on this particular example. And because we use tabulation, we will store those sub-problem answers or sub-problem results in a table or an array or a list in Python which is usually called DP. Yeah, and this will be a 1D array of results for all the subproblems up to final answer. Yeah, and in most cases you need a base case here as well. Yeah, and the base case will be 0. What? So the DP of 0 will be 0, and then you have most of the time some kind of loop, 1 or 2, could be multiple. In this case, we will have a nested loop because we have all the coins to choose, and also we will go amount one by one up until we reach this amount. And basically our subproblems are the answers to smaller amounts up until this one big final amount. Yeah, and of course the base case is 0, which we have already discussed when we mentioned the third example. And then how many entries do we need? How many cells or how many elements in this array should exist? We will have normal case, yeah, and there will be results, or not, sorry, not the results, amount plus 1 entries. Yeah, so the size is amount plus 1 of this table. Why? Because we will be trying to fill it up starting from 0. We already have the base case, and then going one by one up until we arrive at this amount. And the normal case is, of course, based on the previous cases. That's the whole point. Should be the minimum between its value and how can I make it bigger? Like this. And the value that we stored in some previous case for some previous coin. So let's on index I minus C plus 1. Yeah. And what is C here? We have to try all the coins. Yeah. So for C in coins. And basically we will be doing this. And we store, this is the number of ways, yeah? Number of ways or the minimum number of ways or maybe coins we need to get to the amount equal to I, yeah, where I is the index amount, like this. Yeah, so to get 0, we need 0 coins, of course, and then to get each next I, we either store the minimum between what we already have or between using 1 coin plus 1, yeah, between not 1 coin plus 1, the value that we stored before for some coin. So let's say the coin is 2, yeah, and then we have, let's say, some number of ways on this previous cell in our table for that particular coin and that we can use it. That's why it's +1 if we choose to use it, if it's better than what we already have. Yeah, and better, of course, means it's smaller than the number of coins. And let's now maybe use it for this example and see how it goes. So let us create that DP, and we start with 0, and then we fill everything with infinity. And how many cells do we have? We have amount +1 entries. Yeah, so this will be 4, 8, 12, and amount is 11 +1 for this first. And now we can iterate. Yeah, and for I equal to 1, because here already we have filled the 0, we will have the following option. So 0 stays the same, and here we have to iterate through each coin. And the coins are 1, 2, and 5. Yeah, so does this exist for any of the coins? Well, I is equal to 1. 1 minus 1 is 0. 0 plus 1 is 1. We can fill it here. It's the best option that we have found so far. And then the next coin is 2. I minus 2 is minus 1. Doesn't exist, and doesn't exist for bigger coins. Yeah, so that would be the state of our DP array after this iteration. Then the next iteration is 2. And in each iteration, we update a single entry. And so first we have this, then we update this, and now we update here. And so, of course, the infinite is not as good as, let's say, we can arrive at 2 using either 1 plus 1, yeah, which will be 2, or using just 2 when we have I minus 2, which is 2 minus 2, 0, 0 plus 1 is 1. So that would be the next option. And the next, I hope you are getting it by now. We are thinking about the next index, yeah? And here on index 3, we can arrive either by choosing 1 plus 2, yeah, or 2 plus 1. Yeah, or this is the only 2 options. So either way, we will have to use 2 coins. Yeah, and now for 4, we should be able to use 2 coins as well. Yeah, 2 plus 2. And then for I equals to 5, we can again use just a single coin. And because we can use 5, I minus 5, 5 minus 5 equals 0, and 0 plus 1 leaves us 1, and that would be the smallest amount possible. Yeah, and we can continue like this 11 times, but the answer will be, the final answer will be 3. Yeah, but I hope that you get it from this short presentation, and so on and so forth. So now let's try to put it here. So the original DP is 0 plus infinity times amount. And this could be like some maximum integer that we can fit in Python, or we can just use amount plus 1. And this would be also an infinite number for the sake of this problem. And then we have those two loops. One is for I in range 1 to amount plus 1. And the second loop is for all the coins, for C in range, for C in coins. And then we want to use this. Yeah, let's copy that and use it here, but we have to check if this is greater or equal to 0. And that's it. And then we return dp on index amount if it's not equal to infinity, because it could be the case that we don't have any coins to reach that amount, and then we have to return -1. So let's try for the first 3 cases and see how it goes. I forgot colon. It works for the first 3 cases, and now let's see for all the cases. And we are better than 57%. Let's see if we can get a better result by rerunning. And no, we got worse result. I think it can get up to 60% with this particular solution. Can try one more time, but there are other approaches to solve this problem as well, which might be faster. Yeah, so here we beat almost 60%. Yeah, so this is like the most basic and the most fundamental approach using dynamic programming, but there are other approaches as well. And let's take a look into time and space complexity of this particular problem. And the space is only influenced by this variable, by our table, our dp table, and it can be up to amount. So it's O of amount, yeah. Space complexity, and we have 2 loops, and so the time complexity is amount times coins. Yeah, so it's influenced by both of them.